Hi everyone, today in Integrated Math 2, we're going to go over Chapter 11, Lesson 3. Here are the objectives. Make sure you write them down in your notes. Alright, let's go over one of the theorems. In the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So what we're saying for our example here is we have arc FG. This arc FG more or less is here, and we have arc HJ. And we're saying that these are congruent. Because we know these are congruent, then we can say that their chords FG and chord JH, they are both congruent as well. And this also goes vice versa, which means it goes both ways. Next thing we have is if a diameter or a radius of a circle is perpendicular to a chord, then it bisects the chord at its arc. Remember, perpendicular means that it's forming that 90-degree angle. So we're saying if diameter AB, this one right here, is perpendicular to the chord XY. And because of that, we know that forms that 90-degree angle, first of all. Because of that, we can now say that the chords XZ and ZY, these are both congruent. Because we know that these chords are congruent, then we can also say that their arcs are congruent. So arc XB and arc BY. Next, the perpendicular bisector of a chord is a diameter or radius of the circle. So let's look at our example. Remember, we have perpendicular, meaning that 90 degrees. So here we have chord AB. It is a perpendicular bisector of chord XY, which is why we're showing that they're congruent. Then chord AB is a diameter of circle C. So this is just the converse of the first theorem that we just talked about. Our next theorem is in the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. So if we're looking here, we have chord FG, which is congruent to chord JH, which I'm marking here. If and only if segment LX is equal to segment LY, which is shown right here. And there we go.